Okay, I'm Maddie, and we're going to be talking about the greatest common factor today. So, if we're talking about the greatest common factor, we need to review what a factor is. So if I want to factor 12, I'm going to use the factor tree, and I know that 6 times 2 equals 12. And 2 is a prime number, so I can leave that one. And if I factor 6, I know that 2 times 3 equals 6, and these are both prime numbers. So we have 2, 2, and 3, and they're all prime. So I know that 2 times 2 times 3 equals 12. So this is factored. Let's go a little deeper. This might be helpful to some of you. If I want to factor 12 again a different way, we know that 12 can be divisible by 1, 2, 3, 4, 6, and 12. So 12 actually has 1, 2, 3, 4, 5, 6 different numbers that it can be divisible by, or factored by 6 different numbers. So if I wanted to find the greatest common factor between 2 different numbers, I would have to do this with another set of numbers. So let's do 6 and 12. And 6 can be divisible by 1, 2, 3, and 6. So what is the greatest number between these two, or the common greatest number between those two sets of numbers? It's 6. And that's how we find the greatest common factor. It gets a little bit more complicated when we use bigger numbers and more numbers. So we could use 3 different sets of numbers, and it can be harder. Let's try a different way of factoring, or of trying to find the greatest common factor. I watched a video about the ladder method, and some people call it the birthday cake method. So let's do 24. I'm going to use a different marker. (24) and 36. You draw a little upside down birthday cake right there. So we know that 24 and 36 can be divided by 2, and that is divided equally by 12 and 18. We make another little upside down birthday cake like that. Can everybody see that? I don't know if it's dark enough, but and these both can be divisible by 2 again. 12 divided by 2 is 6. 18 divided by 2 is 9. Make another one. So you see how this is turning into an upside down birthday cake? Now the common divisor of this would be 3. So 2, 3, 6, 9, that's 3. So we know that all of these are prime now, so we can't really divide this again. So to find the greatest common factor using this method, we make another big L right here. Here, I'll draw this. Make another big L right here, and we multiply these, just these. So 2 times 2 is 4, times 3 equals 12. So we know that the RGCF of this is 12. Let's try another one. Okay, so let's try one more set of 2 numbers using the ladder method. You have 36 and 72. Make our upside down birthday cake. And we know that 2 can go into both of these because they're both even numbers. So we're going to put 2 over here. And we know that 2 goes into 36 18 times. And 2 goes into 72 36 times. Alright, so if we use 2 again, we can get, that gives us 9 down here. 2 goes into 18 9 times. And 2 goes into 36 18 times. Okay. So 2 doesn't go into both of those, so let's use 3 because we know 3 goes into both of those evenly. 3, 6, 9. So 3 goes into 9 3 times. 3, 6, 9, 12, 15, 18. 3 goes into 18 6 times. And now right here we can use 3 again. 3 goes into 3 1 time. 3 goes into 6 2 times. And these we can't do anything with, so we leave those. Now make our last L, and we multiply these numbers. So 2 times 2 times 3 times 3. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 equals 36. So we know that our GCF, my marker is running out of ink. Okay. We know our GCF is 36, which is in our actual problem. So we have 36 right here, and our GCF ends up being 36. So we didn't really have to do all this work, but if we really pay attention to our first two numbers, we could probably figure it out from the beginning. But if you need to do all this work to figure it out, that's probably your best choice. Okay, so now I want to work on a problem with 3 different sets of numbers. And with the GCF, it's important to remember that there's a lot of different ways that you can find the GCF. So it's not just one way. So whatever way your brain works, use that method. So for the 3 different sets, I want to use 12, 36, and 18. And I'm going to use the same way I showed you at the beginning with, I'm just going to write out the factors. That's easier for me whenever I use 3 different numbers. So it's whatever works for you. You could probably use the ladder method or the birthday cake method with 3 different, but it works better for me to use the 3. That's the way my brain works. So 12 can be factored into, we did this earlier, it was 1, 2, 3, 4, 6, and 12. 36 factors into 1, 2, 3, 4, 6, 9, 12, 18, and 36. So that one has quite a bit of a list, doesn't it? Let's do 18. 1, 2, 3, 6, 9, and 18. So this one's pretty easy. We can just look at the set of numbers. They all have 1, 2, and 3 in common. So we know that it could be 3. They also have 6 in common. So now we know it's not going to be 1, 2, 3. It can't be 4 because 18 does not have that. It can't be anything else because not all the other numbers have it in common. So our greatest common factor between these 3 numbers is going to be 6. So if you're taking anything away from this, I want you guys to remember that learning the GCF and teaching yourself it, the best way to do it is find a way that you can remember, because everyone's going to want to do a different method, and there's many different ways that you can learn to do the greatest common factor. So I hope I showed you the ladder method, and factoring it out can really help too.